Okay, students, welcome. And today I am going to take a problem in simplex method. This is simplex method. We are going to do this LPP problem by simplex method. Given maximum is at equals 2x1 plus 3x2, break 2. x1 plus x2 is less than or equal to 1. 3x1 plus x2 is less than or equal to 4, where x1, x2 greater than or equal to 0. Okay. Now we'll have some ink so that it will be very easy for you to understand what I say. Right here, this is what we say objective function. Objective function, we say this is objective function. Okay, now, and we know that these are constraints equations. Okay, and this is called fusible condition. FE, fusible condition there. Okay, x1, x2 always greater than or equal to 0. Right, so this totality, you take all these things together, we call LPP model. Right, now in solving this by simplex method, the first step is standard form. What is a standard form? Now standard form means, see here, this is less than or equal to sign coming here, that by introducing a slack variable s1, we can make this unequal to into equal to. By adding another slack variable s2, we can make this inequality into equality by introducing an s2. So now this we have introduced the s1 and s2 here, s1 and s2 here we have introduced here, and that you put here with the 0 coefficient with the objective function. This is what we call objective function. Add that with 0 s1 and 0 s2. So now the new objective function is z equals 2x1 plus 3x2 plus 0 s1 plus 0 s2. This is called objective function now. Okay, or modified form. Sorry, this is called the standard form. Now next one is what we call modified form. What is a modified form? Variable one side and variable one side and a constant other side. Constant on the other side is called a modified form. This form is called a modified form. This is called a modified form. Now look at this objective function. You bring this 2x1, 3x2 and 0 s1, 0 s2 this side. You will have minus 2x1, minus 3x2, minus 0 s1, minus 0 s2 plus z is equal to 0. And then if you bring this constraints here, you will get this constraints here. You will get x1 plus x2 plus s1 plus 0 s2 plus 0 z is equal to 3. And you bring the third constraints, you will get like this: 3x1 plus x2 plus 0 s1 plus s2 plus 0 z equals 4. Right. So what you see here, the constant on one side and the variables on the other side, such that all the variables are included there. All the variables are included. x1 is included, x2 is included, s1, s2 and z included. Such a way we have to write on the left hand side. Now what is the next step is that we are bringing all this into a tabular form. Now look at this tabular form here. This is called what? A simplex table. A simplex table is nothing but writing the variable at the top, x1, x2, x3, s1, s2 is that constant basic variable. And what are the coefficients here? See here, minus 2, x1, x3, that you are writing here. And then what are the x2 coefficient here? It's minus 3, 1, 1. You substitute here like this. Okay, then the coefficient of s1 is minus 1, 0. Here you'll get here here 0 coming here, that yes, that will not come there, so you'll get this one. And the s2 coefficient here is this. Okay, so here that's what you are seeing here. The coefficient of z is 1, 0, 0. Coefficient of z is 1, 0, 0. Last one is constant here, and this constant you are writing here. You will get this constant. Now some variables are in canonical form. Okay, canonical form. Some variables are in canonical form. Canonical form. What are the canonical form? S2 z, then one more s1. These are in canonical form. So the canonical form variables you are writing here, and that we call it a basic variable. This is called a basic variable. So s1 equals 1, s2 is equal to 4. You substitute that in the, you will get z is equal to 1. Okay, these are the basic variable. Now optimum, next step is that actually this is test for optimality. That's next step you have to understand. Test for optimality. Test for optimality. That's the next step. Okay. Test for optimality. Whether the optimum is reached or not, look at this maximization problem. This one is maximization problem. But in that particular row, we have some negative numbers there. We are seeing them some negative number. Okay, I will change the ink so that it will be very easy to make you understand that. I will take white ink. Now look at this. There are two negative numbers here, etc. This will damage or aim that to reach the maximization. Am I correct? The maximization aim is damaged because of these two negative numbers. So our aim is to reduce the negative numbers here, but 1 minus 3 is there. That minus 3 will reduce, and that is incoming variable. To move outgoing variable, we need this minimum replacement ratio. 1 by 1 is the minimum replacement ratio here. Look at this here. So corresponding variable is 1 by 1. That corresponds to this 1. This is the corresponding variable 1 here. Okay. Right, so pivotal element. This is what we call pivotal element. This pivotal element we have to make it 1, and here 0, here 0. That's the next step. And next simplex table. This we are making it 1, and here 0, here 0, here 0, here 0 we are making. That's the next table. Look at this. This is a previous table there. Our aim is to make here 1 we have to make, and then here 0, here 0. Okay, here 0, here 0. So if you do this operation, we will achieve our goal that this is 1. Now you multiply this equation number 2 by 3. This equation number 2 by 3, add with this, you will get 0 here. Okay, so multiply that equation number 2 by 1, add with this, you will get 0. Similarly, multiply this by -1, multiply this by -1, then add with this. That's what is given in this equation. This equation brings that to 0, 0 in canonical form. This is in canonical form, and that steps make that to bring in canonical form. Okay, so after doing this, multiply this by 3, add with this, multiply this 3, add with this, multiply this by 3, add with this, multiply this by 3, add with this, we'll get a new equation number 4. Now similarly, multiply equation number 2 by -1, add with this, you will get this step. That is equation number 5 you will get. Okay, now test for optimality. In the Z row, all are positive. In the Z rows, look at this Z row, all are positive. So negative number comes here, no negative number here, no negative number here, implies the optimum is reached because of all are positive number there in the Z row, implies we have reached maximum reached, and actually it is not maximum, optimum is reached. Optimum. Optimum is reached. Optimum means it may be a maximum or minimum according to the problem that we have here. According to the problem we have, this is maximum. In some cases it is minimum. In our case it is maximum, so maximum is reached. Okay, now what is the solution set here? Now look at this, x2 is equal to 1, s2 is equal to 3. This is a solution set. The variable not coming here, those values are 0. Okay, so here implies x1 is 0 and s1 also 0. The variable coming here is a basic variable, other variables you are taking as 0. Substitute this value in our objective function. Okay, objective function is what? Go back, here is our objective function. Okay, in this objective function we have to substitute those values that we have got just now. X2 is equal to 1 and S3 is equal to 1, S1 is equal to 0 and X1 is equal to 0. Substitute all these variables in our objective function. 2 into x1 plus 3 into x2 plus 0 into s1 plus 0 s2. Substitute here. X1 value is 0, so this is 0. X2 value, x2, where is that? X2 value is this, so it's substituted here. Yes, 0 value, and then you substitute that value, you will get maximum z is equal to 3, and this is a solution. Optimum value, in our case it is maximum. So thus we can solve any problem by simplex method. Thank you. I am DrJ. Okay. Thank you. God bless you.